In this video, we're going to talk about rational functions and slant asymptotes. That'll set us up to where we've talked about all of the parts a rational function could possibly have. In our next video, we'll do an example where we kind of try to put it all together. All right, when I look at this rational function, right away I can say, well, I can't factor the top at all without using complex numbers. So I'm not going to be able to cancel anything out with the bottom. So it's in lowest terms, and I have a vertical asymptote at x equals 1. Because if I set x minus 1 equals 0, I get x equals 1. So at least I know that. I'm going to have a vertical asymptote at x equals positive 1. So let's go on and sketch that into our graph. A nice happy vertical asymptote at x equals 1. All right, well, what I notice about this is a situation where the degree of the top is more than the degree of the bottom. So there's no horizontal asymptote. But I hinted in an earlier video that when the top has degree exactly one more than the bottom, something special happens. And I want to check out what that is. Well, let's divide these two polynomials. That's what that says to do anyway. So I have x squared plus 0x plus 1, and I'm dividing by x minus 1. And we could use synthetic division to do this, but I feel like using long division. X times x squared minus x. We need to change our signs to subtract. The x squared's canceled, that's always by design, and I have an x and a plus 1. All right. Make some more room here. So I need to multiply by, well, let's see, I think I need to multiply by plus 1. And I'll get an x and a minus 1. Let's change our signs to subtract, and we get a remainder of 2. That means that this fraction we started with is equal to the quotient, x plus 1, plus the remainder over what we were dividing by. All right, so you didn't see me write that down up here, but the quotient plus the remainder what we were dividing by. Sorry about that. All right, so our long division gives us a quotient and a remainder, and then we can put that together to reformulate the function. Now I want to imagine that I let x get really, really big. Well, if x gets really, really big, I have 2 over x minus 1. This part would go to 0. The bottom of that fraction would grow without bound, and 2 divided by something really, really big is something really, really small. When x gets really, really big or small, plus or minus infinity, it's like this part goes away, and the graph starts to behave like that line. This is called a slant asymptote. Sometimes you'll hear people refer to them as oblique asymptotes. All right, this is a line with a y-intercept of 1 and a slope of 1, so it's this slanted line. There's my slant asymptote. And when x gets really, really big or really, really small, my graph's going to get closer and closer to its slanted asymptote. So let's plot some x's and find some y's. Plot some x's and find some y's. Easy for me to say. Oh, let's use minus 1, 0. Can't use 1, that's where my vertical asymptote is, 1 and 2. And we can just plug them into the original function. So on top here I'd have minus 1 squared is 1, plus 1 is 2, and on the bottom I'd have minus 1 minus 1 is minus 2, I get out a minus 1. If we plug in a 0, I'm going to get out a 1 over a minus 1 is a minus 1. So let's see, at minus 1 I have a minus 1. At 0 I have a minus 1. And maybe we'll sneak one more value in there somewhere to figure out what's going on. But at 1, well, I can't plug in 1. We said that, and I wrote it down anyway. So let's pick 2 and 3. All right, so 2 squared is 4, plus 1 is 5 on top. And I get a 2 minus 1 is 1. I get out of 5. 2, 3, 4, 5. And if I plug in a 3 on top, I get out a 9 plus 1 is a 10. On the bottom, I get a 2, so I get another 5. I get another tie. All right, so let's plug in some values to this function to help us out. I'm going to go to my TI-83 to make this a little easier to see. So I have an x squared plus 1 divided by an x minus 1. I'm going to use the table feature of my graphing calculator to find some values. I have it set up, if I hit second window, I have it set up to ask me what the independent variable should be so that I'm in control of what goes in the table. And so far we've plugged in a minus 1, a 0, a 2, and a 3. I just want to plug in a few other values without having to work hard. So I'm going to plug in a minus 1/2. You get out a minus 0.833. So just something a little bit like that. So I think what's happening is I'm connecting these dots like this. I get closer to my slant asymptote. I get closer to my vertical asymptote. All right, let's plug something in like 2.5. And we get out a 4.83. So let's see, 2.5 and not quite up to 5. So again, I think I'm kind of seeing a shape that does that. I want to get closer to my slant asymptote and closer to my vertical asymptote. Well, I'm going to mash the graph button and see what the calculator says. And hey, that's what it looks like. Let's sketch in the line y equals x plus 1. And there's a nice, happy slant asymptote. All right, how do we find slant asymptotes? We do the division, and the quotient is our slant asymptote. Y equals the quotient is the slant asymptote. All right, you can use long division or synthetic division. We just have to find the quotient. And one thing to note, this only works when the degree of the top is exactly 1 more than the degree of the bottom, because that makes the quotient a line. All right, so that's it for slant asymptotes. In our next video, we will do an example of graphing a rational function where we find all of its interesting characteristics.